This video introduces Parsing, differentiable parsing and visual grounding of verbal instructions for object placing. This research focuses on object placement tasks instructed by natural language. In these tasks, humans verbally instruct robots to pick up an object and put it in a specific place. However, spatial relations in language expressions can be ambiguous. The ambiguity in reference expressions about objects results in a reference expression being grounded to multiple semantically identical objects. We refer to this issue as referential ambiguity. Furthermore, there are also issues of positional ambiguity, which arises from the phenomenon that people tend to describe directional relations without precise distance. To describe the desired state of a complex scene, one can compose many simple sentences for reference and their relations to form a complex language sentence. This property increases the data required for learning compositional language instructions. We address the issues by introducing Parsing, a parsing and visual grounding framework for language-conditioned object placement. Parsing integrates parsing-based methods into a probabilistic, data-driven framework. It exhibits robustness from its data-driven property, as well as generalizability and data efficiency due to its parsing-based nature. The core idea behind Parsing is to leverage structures in linguistic and visual inputs to extract object-centric relations for reasoning and placement generation, and encode those procedures in neural networks for end-to-end training. It learns to parse language into relational triplets from the grammatical structure. The triplets consist of the subject, relation, and object phrases. It then grounds the mentioned objects to the regions in the visual scene. We project the language and visual features into the same embedding space, and evaluate their similarity for grounding object reference expressions. A graph formed by grounded triplets is fed into a GNN for relational reasoning and generating placements. The GNN encodes a mean field message passing algorithm to minimize the reverse KL divergence for the target distribution. As an ambiguous reference expression can be grounded to multiple semantically identical objects, the distribution of correct placement could be multimodal. We represent a distribution of object positions by a set of non-parametric particles throughout the message passing. The particle-based representation can adapt to the uncertainty of instructions with referential ambiguity. We show that our approach can ground spatial relations with positional ambiguity and generate the multimodal distribution of object placement conditioned upon the instructions with referential ambiguity. Our approach can also deal with instructions with seen or unseen compositions of seen spatial relations, with or without referential ambiguity. Moreover, we test our model with human-labeled instructions to test natural requests from human beings. Those instructions contain unseen, noisy expressions. Our approach exhibits strong robustness against those expressions. Thanks for watching.